Well, good morning. Thank you so much for joining me here in my shop on May 27th. It's just about the end of May. Another beautiful sunny day. Oh my gosh, every day is full sunshine here for days now, and days to come apparently. And you know what? That comes with clear nights. And I think I mentioned a couple videos ago I had acquired a new telescope, an electronic telescope, we could call it that. Not one you look through. It's called a Dwarf 2. I'm not trying to promote it in any way. I'm just telling you what I'm doing because I'm having a ball with it. I really am. So those beautiful clear nights are really paying off. Okay, maybe at some point I'll show some astrophotography once I figure out what the heck I'm doing. Yeah. Now what's going on here? So this radio exhibited an oscillation when the IF is peaked. When I peak up these IF trimmers, it breaks into oscillation. That's not an uncommon thing in radios. Usually it's from a lack of decoupling, a lack of a capacitor working right in it. So I changed all these wax capacitors in the radio, expecting at some point when I changed one of them anyway, the oscillation problem would just go away, but it didn't. In fact, it almost seems worse in a way. I don't think it is, but you know, a lot of this is just subjectivity on my part, just listening to things and I'm not taking measurements and the like. So I think an interesting question is, what is going on with this radio that's making it oscillate? How can we even figure that out, since it appears to not be a capacitor, which is, you know, always the likely culprit? Well, I think what I'm going to do, this probably won't be a long video again because, as I mentioned, the sun is shining and I have lots of things to do outside. I think I'm going to look at the signals that are emanating from this radio by using my SDR radio. That's this little box here. So I'm going to put the display from the SDR radio on the screen in a moment, and then I'm going to turn on the radio, and we're just going to look at the different signals that show up on the SDR display. Some of these signals may be kind of invalid or unimportant, and it might be a little difficult to pick apart what's going to be there, but we will do that. I will get all that set up now. Sneak in a little bit of coffee too. Okay, you can see the SDR frequency display on the screen, the radio here. So the objective of this test is to turn on the radio and watch what kind of signals appear on the display up above. Now there's already a bunch of signals there, and they have nothing to do with this radio, I'm pretty sure. Yeah, I'm willing to do the strangest stuff here. So now, where's that getting picked up from? You know what? I haven't even put on the antenna yet. Wait a minute, got the video turned on too soon. Let's stick on something here that'll do the job. Okay. So I'm going to put a very simple little coil of wire here. It's nothing more than a clip lead, like this. So this will be the antenna to the radio. You can see what's going on already. All kinds of signals there. Now, how are we ever going to see what's coming out of this radio if I've got all this stuff already? That's a good question. Might be a little challenging here. So I'm gonna tuck this back here behind here. Okay. Wow, I missed all that radio noise. We're gonna try to spot a couple things. One we should spot quite easily is the local oscillator in the radio. The radio is tuned to, I'm gonna tune it to 1 million here. Well, that puts the local oscillator about 455 above that, so about a million, a little bit below 1500, a little bit below 1.5 million. So that would be somewhere around here. So I expect, I can't put my finger up there, something to pop up on the screen just above where I have my finger there. Stronger than all that noise. Boy, if there's another signal and it's not that strong, we're not going to see it. But I think there is another signal. Are we ready? I'm ready. Okay, the radio's ready to come on. All eyes on the screen there. Hello, come on. Waterfall display is useful for this exercise. Radio's on. Well, I didn't even see a local oscillator pop up. A little bit surprising. We'll make it move. There it is. It's above my finger right here. That's the local oscillator. So again, we'll put this tune to 1,000,000. The local oscillator should be around 1500. Looks like it's around 1450. That's about right. Okay, so no question, what we can see moving there is the local oscillator. Now, what else is going on? If the radio is developing a fixed oscillation, then it's not going to move around. And I'm not going to see it by doing this. I don't even know what's going. I don't even... Wait a minute. Let's bring it on and off and see what happens here. Okay, I'm going to make it squeal. So when the oscillation starts, it generates an ADC voltage in the radio. I'm pretty sure that's what's happening, and it quiets the radio down. So you know the oscillation has started just by the radio getting quiet. You can't hear the oscillation because it could be the oscillation itself is way out of the audio range. It's a radio frequency oscillation, that's my guess. The only reason we can hear it sometimes is because there's another signal, the local oscillator, and the two of them are mixing together and producing an audio, and the radio's designed to have that come out the speaker, and fooling the radio kind of. There it goes into oscillation. And there it is. I thought we'd have a better luck. Now it could be because of the position of my pickup coil. Let's try a few different positions here. Right on top of these coils. I don't know if I'm gonna. I mean, it'd be nice if it wasn't all that noise up there. This would be hunky dory. Sure isn't right now. Now maybe it has something to do with the capacitor over here. What the heck? My stomach growled in the radio. It's picking up stuff in my stomach. Okay, now let's put it right around. This is crazy. We'll put it right around the oscillator coil here because it's in a really good position, the pickup coil. Put it around the oscillator trimmer. That's what I meant to say. Let's kick it in and out now. Oh! So that's the local oscillator there, that tall thing that's showing up. Well, why is it going like this? Can we hear anything like that? Where'd it go? Well, it was going up and down there for a moment. Okay, tune the radio a bit. Okay, so I think the radio is going to be oscillating on its own in the IF frequency down around 455. So 455, we're not even looking at. It's way down here. Is there something going on down there as I tune this? Nothing. Am I just kidding myself? This is fading out because I'm just knocking the alignment way out, and there is no. I gotta turn way up here. Well, this isn't going well. Maybe the pickup coil is just not in the right place. I've got it kind of focused on the oscillator here. I really want to focus it on the output of the IF. And that would be around the detector tube. Now the detector tube is shielded. Is it? Is it really shielded? Okay, there goes my alarm that I can't turn off. No, I didn't win something just now. I'll show you the clock. It's kind of a cool clock. (9:43), which is roughly the correct time. See, the problem with this clock is you can't read it unless you have a white background. You really can't read the time without a nice, you know, kind of cool. I thought it was cool because it looks like it's vacuum tubes. Yeah, but you know, the whole thing's made up of two buttons. Two buttons to, yeah, right. Two buttons, too much for me. Now back to this. So I've got the pickup loop around the tube itself. Not sure how effective that would be, and we'll fiddle around here. Oh! That's a little interesting. Now something did come shooting up at 450. Now I'm not tuning the radio, so I'm not presenting signals from the antenna and varying them by tuning the radio. So any variation is from what I'm doing here with the screwdriver. Very slowly turning it here. So something right around 455 is getting bigger and bigger. Whoa! Where did that come from? Let's go back a little bit. Now you hear the change? So I think the thing we see in the IF, which is right over here, the 455 coming out, is actually a signal coming through the radio. I'm going to tune the tuning, and maybe it'll go away. Sure enough. Let me tune till I get nothing there. Yeah, so if you've never studied the output of the IF as you tune a radio, it's very interesting. See how things are kind of rolling through? There's a very interesting effect there that I'm spotting. So what I'm seeing is, as I tune, the signal comes up, it slowly moves through the IF, and then it should just disappear and go away again into the noise. And then the next one should show up and then go away. But what I'm seeing is, as it's going away, a small guy appears and goes the other direction. Now, am I full of crap? Let's watch one here. Let me just get back to where it's hard to find a spot where there's nothing. Okay, watch that one come through. And there goes the other one. It's going the other way. Okay, there's another one coming through. And then there's another one going the other way. Oop, another one coming through. And going the other way. You can see in the waterfall display the waving back and forth. So that signal we're looking at right now is a combination of some signal coming in on the antenna and the local oscillator frequency. The two of them happen to be 455 kilohertz apart, and that's what generates the signal down here. We can see it coming out of the IF. So to get one going the other way, there it is, there he is. What's he doing there? How does he get there? I'm continuing to move the local oscillator in one direction as I tune. Everything going through the IF should be going in the opposite or one direction. It happens to be the opposite direction. How do you get one going up this way? No answer comes the reply. Well, okay, so we have found something interesting here. Very interesting. Now, I'm personally thinking there's a oscillation in the IF itself. You notice I still have the screwdriver in here, but I haven't turned it. So we're not in the full-blown oscillating mode yet. So let me do that. I'm going to tune the radio up a little bit. There we go. Okay, I'll tune it to a spot where there's nothing in the IF, or relatively nothing. Hey, look at that. Now we're going to tune this guy here. Tune the now, so there's something in the IF now. Now let's think about this. An oscillation that's not modulated will not make a sound come out of the speaker. If the IF is oscillating on its own, it's not modulated, unless by accident. The sound we're probably hearing right now is probably antenna signal noise stuff. As I drive this further, everything got quiet. It's probably getting quiet because the IF tuning is off and the antenna signal isn't present anymore. Or it's so weak we can't hear it. There's a combination of things going on here. So I'm going to tune back. Okay, so if I do it quickly, we get an idea where the radio really wants to be tuned for maximum operation. Well, I would say it's right around here. With the IF like that, we've got a fairly well-tuned IF. That's supposed to mean 455 there in my hand. You see, there's something persisting in the IF. Let's see if we can get it. There. I don't think that's coming from the antenna. I think if I turn this back, well, I don't know now. I don't know. Yeah, you know what? That was a regular antenna signal. Let's get it into the oscillating position here. She's oscillating. Now you get the swoosh swoosh sound as you tune the radio. That choop 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 choop. And again, it has to do with there being already a 455 oscillation in the IF, and then you're bringing through other signals at the IF frequency of close to 455 because of mixing way up over here with the local oscillator and the incoming antenna signal, giving you the 455. So it pops out over here, and then as you tune the radio, it moves. As it gets close to the oscillating frequency of the IF itself, you start to hear a heterodyne tone. Okay, so I can't do a great job of imitating it, but nevertheless, I'm sure you're getting the point. Okay, so what I'm doing here is I'm trying to highlight the observational things that we can see, or hear rather. We can't really see them, like you see them on the computer screen. That's the wonderful benefit of using the SDR, but I'm trying to train my ear, which I already got partially trained. So when I hear these things, I know what they are already. So I've already been suspicious that when you peak this up, there's a 455 kilohertz oscillation just running free in the IF, unmodulated, causing a quieting of the radio and causing the heterodyne effect as you tune through. Okay, now that's why is that happening? We really have proven what it is. Why is it? Why is it there? I got rid of the bad capacitors. You know, I did leave one in there that someone else had changed earlier. I wonder. But I think we're going to leave it here because I got to go outside and do all kinds of gardening. Got to make use of the weather. Well, it's good. Hey, let's do something else here just before I do that. Okay, so I'm tuning back and forth, just back and forth. You can see the local oscillator going back and forth above my finger here. What's going on over here? It just so happens I've got this set so we can see the front end tuning too. So we can check this right now. So what I want to do, we're going to look, I guess I gotta keep pointing up this way. Watch this area, okay, and I'm going to try to move that peak to somewhere where I'm sure of it. Just by watching the signals get strong. So I'm focusing on one of them there. It's the third one in, sort of. I'm trying to tune the radio for maximum. Okay, so I think that's probably maximum. So what I'm just to try to be clear, this is what I'm talking about. I've tuned the radio so this signal is maximum. Now we'll take a look at the local oscillator frequency, subtract 455 from it, and see if it turns out to be this frequency, which it should. Now where's the local oscillator? I think it's right above my finger here. Okay, so I can work right on the computer here. So I think the local oscillator is, you know what, I think it's here. I'm going to have to verify it. So I'm going to move the tuning a bit to make the local oscillator move a bit. Yeah, that's it. Okay, I'll put it back. Okay. The frequency is, I can read it on right off my, well, I can do this too. Just float this right here. And you can read it. 1510. Okay, 1510. Because I'm only partway through my coffee this morning, I need to use a calculator here. 1510. 1510 minus 455, which is what I think the IF is tuned to. Whoops, that didn't work. 455. 10, so we're tuned to 1055. What? Wait a minute. This is 60,000 miles off. What went wrong here? No, it isn't. No, it isn't. No, it isn't. No, it isn't. It's just stuff going wrong in my own head. Personal wrongness. So now we'll look at what is the actual frequency, because I've got the radio tuned, the front end tuning right here, or the antenna tuning, 1041, 1055, 1041. That's pretty good. That's pretty good. That's probably one of the reasons why this radio is able to work. And you know what? We can go a little further here. Why not? So I can adjust this trimmer, and I should be able to move that front end tuning right where the red light should be able to move it around. So it went down, come up, you know, and listening to the radio can throw you off. So wait a minute, no, that's not actually the right thing to do. The right thing to do is to say we do it this way. Might as well, I'll do this. Let's do this. I'm doing this. it's almost done. We'll put the local oscillator on an exact frequency of 1,455,000. So I'm going to put the red line there to make this easy on me. 455, eh? So, okay, so this red line is sitting on 1,455,000. That's a million plus the IF frequency. This makes the calculations easy. So we'll go here. Okay, so a local oscillator is putting out a frequency that should
cause any antenna signal at 1,000,000 hertz to come out of the speaker. Of course, there's no signal there. That's okay. Now we'll look at 1,000,000 hertz. Okay, just about got it. I'll put the pointer on 1,000,000. Whoops, don't do that. There we are. So the red line's on 1,000,000. That's where the radio should tune. Now there's no signal there, but there's one right close to it. So I'm now going to adjust the antenna trimmer and try to boost the signal that's just to the right of the red line. Okay, so just have to make it. I'm actually aiming for the red line itself. It's hard to say. I mean, this isn't so sharp. Well, I don't know, right in there. This is a lousy way to do this, by the way. This is not the most effective way, but it's very visual, right? I mean, you really see what's going on. Good enough. Okay, Mr. Radio, let's take you out of oscillation. De-oscillate. There. Let's go down and see what we can pick up here. So we are now tuned to, I'm pretty sure, 590. Which is right around here. If you look in the IF, I'm going to expand this. I'm going to expand this area. It's expanded now. 455 is about here. You see, I'm going to move the red line out of there. You see there's two signals there. One of those is the station, and the other one is the interfering noise. And the separation between those two signals is the pitch of the tone you're hearing. Remember, we're looking just in the IF now, at the output of the IF. Signals going in two directions. They shouldn't do that. All those different noise signals coming through. My impression is the peak isn't. It's not exactly 455. The IF's probably not tuned to exactly 455. So every time I tune through, at the very end, something comes back. Something comes back a little bit. Often it's swamped by the new thing coming in. So you can think of the IF, talking about telescopes earlier. That's it for working on this radio today. I'm going to leave it at that. The IF is a little like a telescope. And you're looking at the end of the IF that's feeding into the detector. If you imagine yourself looking back up the IF, it's like looking at a telescope. And a telescope view of the sky is very, very small. So now, the sky is going by at length, but it's very slowly, but you move the telescope around and you see stuff going by. This is what we're doing when we tune the radio. Well, not really. This is staying still, and we're moving that stuff in the background, like this. And that's what you're seeing popping up around the 455. It's becoming within view of the IF circuitry. Hey, a whole new way of looking at it. I like that. Okay, well, got somewhere. Some new ideas. Asked for why this radio is doing this exactly. Exactly why. Don't know yet. could be a gain. It's just designed in such a way that if you peak the IFs right up, the IF circuits are going to start to oscillate. You just can't avoid it maybe with this radio. Tomorrow we'll look further into what can we do about this. It is interfering with the operation of the radio, I think. It's very interesting. I find it a lot of fun here. Thanks a lot for watching, and we'll see what happens tomorrow. I'm going out to dig in the earth. See ya.